friends, let's discuss a very important question of chemistry. At room temperature or under normal conditions, why CO2, the dioxide of carbon, occurs as a gas. It is a very famous gaseous compound. When we burn many things, CO2 is a main product, right? And it is a very important acidic compound and very important oxide of carbon, the first member of carbon family. The second member of the carbon family is silicon, but its oxide, that is its dioxide, silica, SiO2, known as silica, occurs as a solid at room temperature. Why? The oxides of two elements, first and second of the same family, occur in different physical states under ordinary conditions of temperature and pressure. This is very, very important. Again, SiO2 is a very important compound, solid compound known as silica. It is major part of sand and many rocks, many rocks. So the cause of this, that this compound is a gas and this is a solid, the causes lie in their atomic size and their electronegativity. First, let's say carbon and silicon. Atomic size very small. Its size is 77 pm, very small as compared to silicon 117 pm. Number 2, the electronegativity. Carbon is highly electronegative, that is 2.5, as compared to silicon, that is 1.9. So practically it is found that there is carbon oxygen double bond between two oxygens and one carbon. So one carbon forms 4 bonds with 2 oxygen atoms. 2 bonds are sigma and 2 are pi. Very important thing. This is very important. Okay, please. And in case of silicon, what do we have? The main constituent of silica, जो हमारे पास compound है, silica, the compound or rock or sand, whatever it may be, this silicon forms 4 covalent bonds which have, you can say, polar nature. Okay, and this is a tetrahedral. One silicon forms 4 bonds with 4 oxygen atoms, and this bond is, we can say, quite polar in nature, or it has ionic character, and that is why it is a strong bond, very strong bond as compared to carbon single oxygen bond. Okay, very important. One more thing, the size of silicon is very large as compared to carbon, and if we say that carbon forms this type of structure or unit so that it can form a solid structure, but this type of structure is not possible because of 2 reasons. First, the steric region. Carbon is very small, it cannot accommodate 4 O atoms around it. There will be strong repulsion between the electron clouds of these 4 O atoms, and this species will be highly unstable, or this species is not favored thermodynamically. Is not favored thermodynamically. You see, the energy released here, you see please, is this 1432 kilojoule when this is formed. Okay, but when we get this species, what is the similarity here? Carbon forms 4 bonds with 4 oxygens, but here this carbon forms 4 bonds with 2 O atoms. So thermodynamically, when this species is formed, more energy is given out, that is 1610 kilojoule. So thermodynamically, this formation of this species is favored as compared to this one. So that is why it is not formed, because of energy reasons. Because of energy reasons, and because of steric factor. Here, silicon can accommodate 4 O atoms because of its bigger size. And when this species is formed, more energy is given out as compared to theoretically formed this species, that is O double bond Si double bond O. What we are saying? Theoretically, if this species is formed, the energy given out is 1276 kilojoule. System is more energetic, but when this species is formed, energy given out is 1864 kilojoule. So energy content of this species is less as compared to this one, because this much energy is going out of the system. More energy is going out. That's why this system has less energy as compared to this one. That's why it is more stable and it is favored. It is formed thermodynamically. One more thing. Here, the pi bond is formed between 2p and 2p orbitals, which have almost same size and same energy, and this pi bond is very, very strong. Here, if this species is possible, or if we assume the species exists, the bond formed, the pi bond formed, is in between 3p of silicon and 2p of oxygen. So these two orbitals, 3p and 2p, have different sizes and different energies. And here, bond formed, if it is formed, is not stable, or formation of the pi bond between 3p and 2p is not favored. Okay, because of orientation effect. So what we are saying? So one more thing. Here, this bond, single bond, is highly stable or strong as compared to the single bond between carbon and oxygen. So in this way, we discussed 3 or 4 reasons. That CO2 is a gas, but SiO2 is a solid. Last, this silica or SiO2 formed a 3-dimensional network structure, and the substance is very, very hard. The structure is like this: silicon, oxygen, then we have here, okay, यहाँ से हमारे पास क्या आएगा? Oxygen, right? Then we have the silicon, then we have oxygen, silicon, then here we have the, you can say, silicon, one more silicon, So please, हमारे पास क्या है कि वो here one silicon is bonded to 4 O atoms. 4 O atoms. 4 O atoms. 4 O atoms. O. Then we have the silicon. Then O silicon, O, then O and silicon, O and silicon, 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 silicon. So you see here, if we extend the structure, O, O, and O like this. So this silicon, okay please, let's simplify the structure this time. So you see one silicon, this silicon is bonded to 4 O atoms, and one O atom is bonded to silicon, 2 silicon atoms. And this type of three-dimensional network structure is formed. So what we have, one silicon is bonded to 4 O atoms, and every O atom is bonded to 2 silicon atoms. Okay, and this question is very, very important in chemistry. This is a very, very brief, okay, or shortest representation of the network structure of silica or SiO2. Okay, please. Thanks. Namaskar.